Hi guys, we are still in chapter 4 and we are almost rounding up. In the first lecture of chapter 4 we looked at the diode calculations, then we looked at types of rectification, half wave, full wave using a center tape, and full wave using a bridge rectifier. We also looked at the advantages and disadvantages of each, and we ended up discussing on ripple factor. So we are now going to look at voltage doublers. In voltage doublers, we take advantage of the process of rectification. Then after rectification, we also take advantage of the properties of a capacitor, in that it stores voltage. So we are continuing from there. Our objective remains the same, and I think by now you are now able to do most of 1, 2, 3, 4, 5, and you are now left with the last one, which is the 7th. So make sure by the end of this lecture you are able to describe with the aid of a diagram the operation of voltage doublers and voltage triplers. What basically is a voltage multiplier? This is a circuit that produces a DC output that is a multiple of the peak input AC voltage. So from AC input voltage, we are producing an output that is DC in nature and is also a multiple of the input peak AC voltage. So we've got voltage doublers, voltage triplers that we are going to look at in this electronic course. So a voltage doubler produces a DC output from an AC voltage that is a multiple of 2. In other words, we multiply the AC input voltage by 2 and the output that we get is a DC voltage. For a voltage tripler, even from the English meaning of the word, we produce a DC output voltage that is multiplied, or that is a multiple of 3. So we multiply the input AC voltage, or the peak input AC voltage, by 3 to produce a DC output voltage with that value. So we'll look at voltage doublers and voltage triplers, but it is also important to know that despite the fact that we produce high DC output voltage, there is no power amplification since there is reduction in the current. It is important to note that while there is a multiplication of the input AC voltage by N, there is a peak input current decrease by N. So the actual power output from a voltage multiplier will never be greater than the input power, but in actual fact it is less than due to some losses. Thus, the schematic diagram of a voltage doubler, the capacitors can be polarized or non-polarized, depending on the characteristics that we want. So we can take note how the diodes are connected. The positives, the anode is connected to the cathode, and from the input we've got the first component that we need is the capacitor, and we know that a capacitor, it can be or is able to store charge. So we can charge a capacitor and we can also discharge it. So I think by now everybody understands what is rectification. So we want to analyze the way how that circuit produces a voltage, a DC voltage that is a multiple of the input voltage, and in this case a DC output voltage that is a multiple of the input AC voltage by 2. So the DC output voltage will be 2 times VS stands for the supply voltage, and it is the peak of that supply voltage that we multiply by 2 to get a DC output voltage. So what we are doing in that case, we are charging some capacitors, and those capacitors are able to store the voltage. So let's proceed to the next slide to just get a glimpse of how a half-wave voltage doubler operates. When we are analyzing a half-wave voltage doubler, please take note that we start with the negative input voltage, and I want you to find out why we don't start with the positive input voltage. So it is important to take note of that. So let's do the analysis here. When the input is negative, we have got D1 that is forward biased and D2 is reverse biased as shown in that particular diagram. And the result is that C1 is charged to the peak value of the input voltage, while C2 is discharged through the load. And when the input is positive, or during the positive half cycle, D1 is reverse biased and D2 is forward biased. I think we know that when the positive input is connected to the anode, the diode is forward biased, and when the positive input is connected to the cathode, the diode is reverse biased. That's where those statements are coming from. So we are saying for a positive half cycle, D1 is reverse biased and D2 is forward biased during this positive half cycle. Right, this is what happens. The voltage source and the voltage across the capacitor C1 are connected in series with C2. So what this means is capacitor C2 is going to be charged by the sum of the voltage, the supply voltage Vs and the voltage across the capacitor C1. But we know that C1 is charged to the supply voltage. So what we are saying is capacitor C2 is going to be charged by the voltage across the capacitor, which is the same as Vs peak, and also the voltage from the supply voltage, which is Vs peak. So in other words, the voltage across the capacitor C2 is charged to 2 times peak supply voltage. Hence we are saying we have doubled, or we have multiplied the AC supply voltage by 2. Hence the name half-wave voltage doubler. We are continuing on the operation of the voltage doubler. So we can see that the capacitor C2 discharges through the load after being charged to the supply voltage from the input and also supply voltage from the capacitor. So what are we saying? When we are saying the capacitor is now discharging, especially C2, we are saying it is now supplying power to the load, and we've got what we call the time constant. This means that the time constant, or the time taken for the capacitor to discharge through the load, must be very little, so that it don't lose any of its charge before the reversal of the polarity. So in other words, when the input is negative, C2 discharges slightly, and during the positive half cycle, D2 is turned on, and C2 in this case is now recharged. So we have C2 being charged when the input is positive, and we have got C2 discharging when the input is negative. So C2 barely has enough time to discharge completely, meaning that the load is always supplied with enough power by the voltage from C2. We can simply describe the operation of the halfway voltage doubler from that particular block diagram, and you can see that we have got the circuit input voltage, which is sinusoidal in nature. It goes into the voltage doubler, and what we get out of the voltage doubler is DC voltage with very small ripples. Hence, we are saying the DC output voltage is approximately equal to 2 times the peak supply voltage. And I think you must have grasped where the 2 is coming from. The 2 is coming from the fact that the voltage across the capacitor C1 and the supply voltage Vs peak are in series. So capacitor C2, which is connected to the load, is charged to 2 multiplied by the peak supply voltage, or it is charged to supply voltage Vs peak plus the voltage across the capacitor C1, which is also the same, or which has been charged also to peak supply voltage. We have finished with the halfway voltage doubler. We are now proceeding to full wave voltage doubler. And please take note of the half wave and the full wave. And in this case, we've got 2 diodes, just like in a halfway voltage doubler, but we now have got 3 capacitors, and the other capacitor C3 is in a parallel with the load. So the full voltage doubler is almost the same as the halfway voltage doubler. If you have a look at how D1 and D2 are connected, and also how C1 and C2 are connected, the only differentiating factor is C3 that has been added, and C3 is connected to the voltage across C1 and also to the voltage across C2, meaning that the voltage across C1 plus the voltage across C2 play a very important factor in multiplying producing a full wave voltage doubler. Let's analyze the operation of the full wave voltage doubler, and it's unfortunate that I'm going to explain the way how the circuit is going to operate. Please make sure you refer to the diagram or to the circuit diagram during your own time. When the input is positive, D1 is forward biased and D2, because of their connections, is reverse biased. And please, can you take note that this will charge C1 to the peak supply voltage, and when the input becomes negative, or during the negative half cycle, D1 is reverse biased and D2 is forward biased. This is going to charge capacitor C2 to the peak supply voltage. Because the 2 are in series, the voltage across the 2 is now equal to 2 times peak supply voltage. I will repeat. When the input is positive, D1 is forward biased, and when the input is positive, D2 is forward biased. Because D1 is conducting, it is going to charge a capacitor C1 to the peak supply voltage, and when D2 is now conducting, it will charge capacitor C2 to the peak supply voltage. And because the 2 are in series, it means that the output voltage is equal to 2 times peak supply voltage, and the function of C3, take note, is to act as the filter capacitor to remove some ripples. Right, from that analysis, you can tell that a full voltage develops across C1 and C2, and you can see when the input is positive, you can see D1 being forward biased and C1 being charged, and when the input is negative, you can see that D2 is now forward biased and capacitor C2 is now being charged. Hence the explanation from the previous slide. So we are going to have the output. Please take note that the capacitor C1 and C2 are connected in parallel with C3 and in parallel with the load. This means that the output at the load is equal to 2 times the 2 capacitor voltages, which is 2 times the 2 supply peak voltages. So we have finished the half-wave voltage doubler. We have got an output that is half of the full wave cycle. But for full wave voltage doubler, we have got an output for each half cycle input. Let's look at what happens for a voltage tripler. What we are meaning here is we are going to multiply the input AC voltage by 3 to get a DC output voltage. Please, you must be able to draw that particular circuit, right? The voltage tripler produces a DC output voltage that is 3 times that is self-explanatory. D1, D2, C1 and C2 form a voltage, half-wave voltage doubler. The added components, we now have got 3 diodes, and we now have got 2 more capacitors, C3 and C4, from the rest of the voltage tripler. Right. The first part is the half-wave voltage doubler, which works the same as the previously discussed half-wave voltage doubler. The second is that D3 conducts whenever D1 conducts. So D3 conducts whenever D1 conducts. Why? Because insofar as AC is concerned, their anode and their cathodes are connected together. Please take note of that analysis. It is very, very important, because we now have got a voltage doubler and a half-wave voltage doubler in such a scenario. That circuit diagram is so simple to analyze, and let's try to analyze it. When the supply voltage is negative, D1 and D3 both conduct, allowing C1 and C3 to charge up to the supply voltage. Please take note that our capacitors rather are charging up to the supply voltage, and we said D1 and D2 and D3 conduct at the same time. So if they conduct at the same time, because of the way how the 2 capacitors are connected, as shown by the direction of the flow of current, it means that C1 and C3 will charge up to the peak supply voltage. And for a negative half cycle, we are going to have, because the input is now positive, D2 is going to be forward biasing. That is 10D on, but C2 is going to charge up to the supply voltage plus the voltage across C1, which is 2 times peak supply voltage. So this means that the voltage across C2 and C3, they now add to 3 times peak supply voltage. In other words, we've got 2 times peak supply voltage plus the peak supply voltage, which is the voltage across C3. Hence, we have multiplied the input AC voltage by 3 to get a DC output voltage. I think that slide was explained when it was stated that for a positive input, D2 is forward biased and it is going to charge capacitor after it to 2 times peak supply voltage. So C4 is simply a filter capacitor that is needed to reduce some ripples. And please, can you take note that C2 and C3 are in series, so that we add peak supply voltage across C3 plus 2 times peak supply voltage across C2 to give us 3 times peak supply voltage. If you go through it, it will make you understand better the two circuit diagrams for a positive half cycle and for a negative half cycle. So just go through it, otherwise it is good to note that C4 is chosen so that the time constant, please, time constant is covered in your EET course. Must be very, very long, so that capacitor C2, which is discharged through the load, must not reach a zero value.